All right, so in this video, we're going to solve exponential equations. So there's one rule we have to keep in mind when we're solving this equation is as follows. So if you have, say, a to the power x is equal to a to the power y, then we can say that x is equal to y. So by keeping this in mind, we can solve few exponential equations. So let's get started with our first example. So for example, this one, I have 10 to the 2x minus 3 on the left-hand side, and on the right-hand side, I have 1 over 10. So in order for us to solve this, we kind of want to use this rule up here and then solve for x. So I want to have both sides to be same base. So I'm going to rewrite the right-hand side as 10 to the power negative 1, because that's 1 over 10. On the left-hand side, we still have 10 to the power 2x minus 3. And now we can use that rule up there. We can say, well, if this is the case, then the only way these two sides are equal, if their exponents are equal. So that means 2x minus 3 is equal to negative 1. And then we can just go ahead and solve that equation. So we add 3 to both sides. That would give us 2x is equal to 2. And then we can divide both sides by 2. That would give us x is equal to 1. So there you go. And then if you want to do the check, you can go ahead and plug in 1 into x for this function, and then you will see 1 over 10 is equal to 1 over 10. Let's try another example. So take a look at these examples I have. So we'll do the first one on the left-hand side. So both sides I have e raised to some power. Again, same base, I can just equate their exponents. So that means using the rule we wrote down above, we have 1 minus 2x is equal to 3x minus 5. And then we can go ahead and start solving for x. I'm going to go ahead and add 2x to both sides. So that would give us 1 is equal to 5x minus 5. And then I can go ahead and add 5 to both sides. Right? And then that would give us 6 is equal to 5x. And finally, we can go ahead and divide by 5 on both sides. Hence, we have x is equal to 6 over 5. So there you go. That's our solution to this exponential equation. All right. Now let's take a look at the one on the right side. Now, this one does require us to do a little bit more algebra. So we can start factoring this before we start solving for x. So I can pull out their GCF. So it looks like e to the x is a common factor. And then I can also pull out an x because that's also common. So we are left with 3 from the first term plus x from the second term equals to 0. So we have e to the x equals to 0. And then we have x is equal to 0. And then we have 3 plus x is equal to 0. So we're solving 3 different equations in this once we factor. Well, can e to the x ever be 0? Well, no. From the exponential graph, it looks like this. So we know that it will never be 0. So this cannot be true. Now, x equals 0? Sure, okay, that's already solved. And then 3 plus x equals 0? Well, we get x is equal to negative 3. So there you have 2 solutions for this exponential function. So we use some factoring technique to solve this one. Now let's go ahead and try one more example. So let's try this one. So we have x squared, 2 to the x minus 2 to the x equals 0. Again, it looks like we can pull out a GCF. So I'm going to take out 2x, 2 to the x. Then I'll be left with x squared minus 1 equals to 0. And then you can factor x squared minus 1 just a little bit more. So that's a difference of perfect squares. We get x plus 1, x minus 1 equal to 0, and 2 to the x in the front. So now we set each one of them to 0. We have 2x is equal to 0. X plus 1 equals to 0. Then we have x minus 1 equals to 0. Now we know exponential can never be 0, so that's out. This one gives us x equals negative 1, and this one will give us x equal 1. So there you have two solutions for this problem. All right, so I hope this makes sense. See you next time.